right. Hello. Hi, we are on 11.3. So three-dimensional figures, right? And our topic today is going to be pyramids. So pyramid has a square pyramid has a square base. And then a triangular pyramid has a triangle base. So it matters how tall this pyramid is, right? It also matters what's on the bottom, that there is a square. So we're triangular pyramids, square pyramids, cone, okay? So here we go. The formulas, let's do those first. All right. So volume of a pyramid, 1/3 base times height. Now you're probably wondering, why is there a 1/3? What is that? Well, if you had, you know how like the area of the base is the square. The height goes from the middle straight up. So this black line actually should go like this, because I want you to know that it's from the center of the square up through this top vertex up there, the only top vertex. So, and then the 1/3 is because I'm not, if it were just base times height, that would be like a rectangular pyramid. Oh. Good call, girl, love it. Thank you. All right, the 1/3 is because if it didn't have the 1/3, then it would be a cube, wouldn't it? Just like a normal cube. But the 1/3 is because it tapers up. You know the word taper? It tapers up like a candle tapers up. It gets skinnier as you go up. It's 1/3 the size of a regular cube as it tapers up. So 1/3. Now big B, remember, length times width of the bottom base. 10 times 11 times how high? And this is easy, it tells us everything. 16. You want to come grab a calculator? Maybe you should just grab one every day. Sorry if you need one. You're gonna need one today. All right, you have a calculator handy, you guys. You're all gonna need one. Every day this week, you're gonna need a calculator. This whole chapter is formulas and all that, so. So let's put another thing up here. The homework, trying to figure out what the homework asks us to do, because I want to make sure I say, I like rounding to the 10th place. The homework asks you to round to the 100th. So let's do what the homework says for notes so that we changing it. And you do one thing for notes and one thing for homework. Let's round to the 100th place, the second place. People on Zoom, you really need to do 10 times 11 times 16 first, and then divide by 3. That's what you need to do first. Are you ready? Janet, go ahead.
586.67.
Yep. Inches cubed. Volume of a pyramid. Were you all able to get that? Multiply 10 times 11 times 16 and then divide by 3. Yep.
Isn't that 6 repeating?
Right, but since, right? Okay, let's do number 2. 1/3. The big B is 21 times 9 times the height. Okay, go for it. Someone on Zoom, tell me. Someone on Zoom. It's just a multiplication problem. Let's go.
315
315.
yards.
Yep. Two ladies said it. Thank you. Thank you. 315 yards cubed. Okay, great. Jump down to number 4. So on number 4, I have a triangular pyramid. So the triangular pyramid, my base is a triangle. Which is 1/2 base times height. So on number 4, the base, the big B, is going to be 1/2. Okay, 12 is going to be my base, and then it tells me, see how it goes through, and it tells me with this little right angle right here. See that little right angle? That tells me how high my base is. My base is 7.5 high. So the area of my triangle is the bottom shape. That's my capital B, my big B. So 1/2 of 12 is 6. 6 times 7.5 is what?
45.
45, thank you. So here's my formula. Volume equals the area of the base, whoa, the 1/3, sorry, getting a little ahead of myself. 1/3, the area of the base times height. Times, and look, this is 10 high. Okay, good. The number comes out so nice. What is it?
150 millimeters cubed.
Yes, 150. So triangular base, find the area of that triangle, 1/2 base times height. Now I'm filling in some info here. So one thing I wanted to remind you of that was in yesterday's notes, if I had a cone or a pyramid that somehow had a slant to it, oblique, right? Oblique. Cavalari's principle says it has the same volume. Okay? The volume of this equals the volume of this. So even though it's slanted, it still is the same height, the same volume, pardon me. Okay. Now, on number 5, we're jumping to number 5. On number 5, I have a triangle as my base. This is a right triangle as my base. That means that I've got in my right triangle a base and a height and a hypotenuse. This problem is higher level because if my base is 14, I don't know my height. So right now I don't care about the 19 at all. I'm only looking at this right triangle. So it's 14. Well, I should draw it straight. I don't know how high it is, but I know that it's 22.1 as my hypotenuse. How do I find the height? This is the base of my pyramid. How do I find the height?
Pythagorean theorem.
Pythagorean theorem. I'm going to do it to the side because I need the space. H squared plus 14 squared equals 22.1 squared. Pythagorean theorem. H squared, 14 squared is 196. 22.1. 22.1 times 22.1 is 488.41. I need to subtract 196. H squared is 292.41. My height, square root both sides. Someone tell me that.
17.1.
17.1, excellent. So that means that my height is 17.1. So I haven't even started doing my 1/3 big B times height. Because I didn't know the triangle, it wasn't complete. So 1/3 area, big B, area of the triangle, 1/2 base times height. 1/2 base is 14 times height is 7. Sorry, it just doesn't look good enough. One half base times height. So the formula is, this is the triangle's area. The height of my pyramid is 19. Okay.
Wait, could you explain if you have the formula?
The always capital B is the area of the bottom base. Since my bottom base was a triangle, I had to do 1/2 base times height. The base of my triangle was 14, and I had to find the height. I didn't care about the hypotenuse at all. So see how this is a right angle right here? That's the two sides that are the legs of the triangle. So the base is 14, the height is, I don't know, so I had to do Pythagorean theorem to find the missing height. And here's what the triangle looked like on the bottom. 14 base, I didn't know the height, but I knew the hypotenuse, so I could find the missing side by doing Pythagorean theorem.
But why do we have to find the missing side if we have another height, which is 19?
That's the height of the actual pyramid that I used later on. So the base itself, like this one, had 12 as its base and 7.5 as its height. So I had to find the area of the triangle using the 1/2 base times height.
Oh.
the triangle first, and then how high it goes, it shoots up.
Is that like the height of the base?
It's the height of the base.
Oh, okay.
I know, it's like a lot, yeah.
Isn't that just length times width, right? Width.
As long as you don't use the hypotenuse, this number in it, yeah.
Yeah, 17.1 is the length. If I remember how we measured it.
If a triangle, it could be considered the length, you could say that,
It's length times width. And then
cut in half,
Yeah.
okay. All right, did someone get this though, when you did the math? It's a lot, you've helped, someone else? Yes, please.
758.1.
Ooh, it is 758.1. Meters cubed. Okay. Pyramids. We're done with pyramids. We're moving on to cones. Can I scroll down? Cone, let's do 7 and 8. Cone has a different formula. It has a different formula because the bottom of a cone is a circle. The bottom of the cone is a circle. Man, sorry. Okay. So cone, this pi r squared would be considered the base of my shape. The base is a circle. The area of a circle is pi r squared. So it's still 1/3 base times height, but my base is a circle, so that changes things. 1/3 the base, pi, radius, my radius is 9, squared. Times how high my cone is, and my cone is 17 yards high. So I want you to use the pi button on your calculator, of course. And I do want us to round to the nearest hundredth. Okay. All right. 81 times pi times 17 divided by 3. Someone tell me.
Is it 146.18?
That's too small. Sorry, it's a little too small. Natalia, right?
Yeah.
Yes.
1,441.99.
Good. I like that you still include 1,441 and 99 hundredths yards cubed.
Miss Grant,
Yep.
when you plug in the equation to the calculator, it gives you like 450 or 449 or something like that, and then pi.
459.
Yeah, how did she get 1,441.99?
Because she did 459 times the pi button. So you still have to multiply by pi. So maybe that's something that you forgot. Check and see, try again.
Multiply it by pi, because then it just gives me 459 pi again.
Oh, your calculator, you might need to press like, I don't know, there's a way, you can't leave your answer in pi form. Some calculators have buttons that like have arrows where like it changes on the corner somewhere, or like the ones I have this button and it's got two arrows and it changes from like fraction to decimal, and I don't know. If you really can't figure it out, I guess you'd have to do 459 and you just enter as many digits as you can of pi to get a most accurate answer.
Okay.
Those are just like a few. Okay, number 8. My radius, my diameter is 5, but that's not my radius. So what's my radius? Close.
2.5.
Yep. All right. 1/3 pi 2.5 squared times the height. Pi r squared times height. Okay. Next. What's the
5,235.98 or 98.
pretty much very close. You know what, I think maybe your decimal is at 52.36. Did anybody get that? Okay, so maybe your decimal's in the wrong spot and it would be inches cubed. Oh, we're doing really good because I'm letting you guys look at your tests today. I finished them last night. So fun doing tests at 8 o'clock at night. All right, going to 10. Let's put this into practice. All right, I get to draw a cone and I want you to practice drawing a cone. Drawing a picture for any sort of word problem. Diagram, underlining important information, highlighting, it's all good habits. A cone, great. Has a volume, so I know the volume already. The height of the cone is 8. What's the radius? I can put R. You might like it if I put R. The formula is volume equals pi r squared times height. Volume equals, 1/3, sorry. 1/3 pi r squared times the height. But I was told the volume already. The volume is 1,309. So plug that instead of V. 1/3 pi, I don't know r squared, but I know height is 8. So there's my formula. I knew volume, I don't know radius. So this is a matter of me doing lots. I could multiply 1/3 times 8 first. I mean, I don't think that it's not gonna be a nice number because I end up having to divide it on both sides to get r squared alone. So if I do that method, because I'm really try to combine like terms on one side as best I can. 8 divided by 3. So it's 2.6 repeated r squared. I'm gonna run out of space. Anyways, 1/3 times 8 is 2.6. So I have 2.6 r squared on one side and 1309 on the other. So I'm gonna divide both sides by 2.6. 1309 divided by 2.6666. I mean, you can put as many as you want, but the point is you're gonna get like 490.88. 490.88.
How do we get the 2.6 again?
1/3 times 8. Because I just want to put things, they're on the same side. I could work that out first.
Then what happened to the pi?
It's right. Hold on. Here. So truly, I could have done 8 times 1/3 times 3.14159. That would have probably been more efficient. Because now look at me. I have to do a whole nother step. I have to divide by pi. That was a bad choice on my end. I should have made it less steps for me, but I didn't. Divided by pi.
Is it possible for me to do 1/3 times pi times 8?
Yeah, I should have. I like made a mistake. Because I created more work for myself. But my answer is going to end up being the same. But yeah, and then square root both sides. Um, 12.5 is my radius. Okay. So in this formula, in this problem, Caitlin must build a sandcastle in the form of a square pyramid for a project shown to the left. She bought 3 bags of sand. So she's hoping she has enough sand containing 1,200 inches each. Will she have enough sand? So first of all, she has 1,200, 1,200, 1,200, 3,600 inches cubed of sand. So I need to know find the volume of my pyramid. And then it's like, is 3,600 enough sand? So that's what we're doing here. So have some of you been working on the pyramid volume already? I hope everybody knew, otherwise I'll call on Elise. Don't just wait for me to do the math and then you copy off me. 1/3, sorry, I'll do it real quick. 25 times 25 times 18. Okay, Elise, what's the volume of the pyramid?
3,700.
So the volume of the pyramid is 3,750 inches cubed. Is 3,600 enough sand for this 3,750? No, no. She needs more sand. Or she doesn't have enough sand, however you want to say it. Okay? Good. All right, your homework is the attached paper. And the problems that I want you to do on the attached paper are all the ones that are like circled. Yeah? The digital notebook is uploaded. Let me actually stop the recording, because that would be step one.